This is the Amp Hour Podcast, recorded May 7th, 2013, episode 144, with guest Bob Davidson, Hoodied, HP, Hijinks.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
And this is Bob Davidson with Ambient Sensors.
Hey, Bob. Thanks for joining us.
Hi.
Is it Bob or Robert? It's Bob, right?
I go by Bob, yeah.
Yeah, everyone does, right? All Roberts do, don't they?
Well,
especially here in Australia.
If I hear Robert, I think I'm in trouble.
Robert J. Davidson, come here immediately.
Exactly. Yep, exactly.
Bob is like, the sort of
your
stereotypical
uncle,
name here.
Dave.
Like, he's my uncle. Yeah, Bob's my uncle here in Australia. Bob literally is my uncle. I do have an uncle, Bob. That's how Australian I am. Yep.
That's good. Nice.
Yeah. So tell us about yourself, Bob.
Okay, well...
Tell us your life story.
Oh, gosh.
And go.
I know.
On the spot.
How long do you have?
Well, my parents met at a...
Yeah, right, exactly.
I was just a glimmer in my father's eye.
Yeah. Start out where you're working at the moment and what you do, and then sort of go back and how you got started in electronics, because everyone wants to know that.
Sure. Okay, well, I have a small consulting and product development company here called Ambient Sensors, and it's in Boise, Idaho, and do custom electronic design for all sorts of people. One of the projects that we've been working on recently is a hit detector for football that measures how hard football players get hit, and then alerts them if they should be checked. Which
checked?
Yeah.
What do you mean?
Like a concussion?
It measures the probability of a concussion, and it alerts them if there's a 50% chance
right.
of
I gotcha.
a concussion.
Right. I thought you were talking about the ball. No, you're talking about...
No.
Right.
No, it measures
sensors.
how hard they get hit in the head.
Yeah.
And I was working with the people at the Injury Biomechanics Lab at Wayne State University and another group up in Ottawa called Biokinetics, and they built this tester for measuring
banging heads.
Yeah, and exactly. And
what a great rig to build.
And they got it by studying video of guys banging heads, and so the thing has realistic velocities and forces. But to give you a feel for what it's like, it's really violent. If you put a football helmet on, and then if Dave put a football helmet on, and then let Chris take a baseball bat.
Wait, can we hook this up?
Which he's been dreaming of doing for years.
Yeah, I was going to say, is this a possibility?
No, it's really awesome. The pro players are getting peak G forces of 120 Gs.
Holy crap!
Over impulses that are about 15 milliseconds wide. But
100. That's not many Gs. I mean, if you drop something on a hard surface of a bench, you can get thousands of Gs right there. I mean, G is just deceleration in a given distance.
But when it's connected to a head rigidly, so FEMA, then that's why you have to calculate the energy of the impulse, and it gets pretty substantial.
Yep. Yeah. Which is just basically the area under the curve is the energy of the impulse. Yep.
Yeah, and there's something called the head injury criteria that actually uses that, and it's an experimental curve that was developed actually originally for the automobile crash business, but then it's been extended into this.
So this is like a standard curve, is it? A standard impact curve?
Yeah, that's recognized by the insurance industry and auto crash.
Right.
So this thing has a little 3-axis analog devices, accelerometer, and NXP microcontroller that does all the management of that.
How do you find those MEMS accelerometers? Because I've never used those for shock and vibration testing. I've always used like a real, in quote marks, accelerometer from ICP or from Brüel and Kerr or someone like that.
Right. So You mean in terms of how close they agree?
Like its response, its linearity, its calibration, all that sort of stuff. Are those things any good?
Oh, they're awesome. Actually, I've been doing testing here with what we call a drop tester, which has a laboratory grade accelerometer.
They're the ones I've used, the lab grade ones, and they come with a cow certificate and a response curve and the whole,
and fancy amplifiers and LabVIEW and all the rest of it.
Yep.
And then we drop it into onto a pad that has a certain durometer that gives the kind of impulse that we want, and I get I get very good fits to the data. Like 0.998 for a goodness of fit and things like that when I've plotted one against the other. So it's very good.
Awesome. Okay, I didn't think they were that good. I thought, they're okay for getting a tilt on your mobile phone, but I've always wondered how good they are for actually, linear calibration.
These go up to 200 Gs, so they're really not the same as what you put, although they're similar technology, they're not the same as what's in the mobile phone.
Right.
But the use case before this one for these accelerometers is setting off airbags in cars. And so the ones that are used in that grade of accelerometer is pretty reliable, of course. And so
it'd have to be, expensive.
Good one to use.
So all you pussies wearing helmets in your sports over there, because we don't have, we don't wear helmets here in our football.
Right, exactly.
So that's
Look how that
is it
turns
just
out.
in the helmet? Is it, or like you got
Actually,
them on the body and stuff like that?
In this case, it goes in the chin cup, the part that holds the helmet onto the, and they wear them very tight, and it's very rigid. The overall combination of chin cup, helmet, and skull forms a pretty rigid body. So we do a lot of correlation work, and actually one of the things we have to take into account is the angle of the hit, and so we can compensate.
I was going to say, can you determine the angle of the hit?
Yeah, I can because of the initial acceleration, I can work it out.
Right. Yep.
So is this all? Did you actually beam it over to like the sidelines or something, or is it data logging so that once they are hit, they just kind of pull it off and see?
Okay, so the other side of this is that we wanted to make one that was affordable at the high school level, because that group of players is probably the least observed.
Right, and
most,
the most
vulnerable.
Yeah, and the most career ahead of them.
Hopefully, exactly. Hopefully, and they have. The system that I've been building only stores the data locally and uses a USB connector to download it. We looked at wireless, and that could be an option later, but the wireless is just not reliable enough. So what we do right now is at least for the low cost stuff over an area of the size of a football field with all the other interference around it. So what we do is we have a very bright LED, and when the player gets hit where there's a 50% chance of a concussion based on that curve I mentioned earlier, it flashes bright red, and they're supposed to go off and get checked to see if they actually did suffer a concussion.
At least change the helmet out.
Well, I can see this becoming like a crowd thing. Like, if it goes, if it pulses bright red, the crowd erupt. Hit him again.
That was one of the worries, actually, is that people start trying to.
Yeah,
right.
They would hurt each other more, right?
It's like that. Like in the carnival where you hit the hammer down on the thing and try to ring it.
Right. Oh boy!
But I am actually on a national committee that's setting standards for this, because there will be eventually standards for like how many hits. So one of the issues is not so much the concussions, although those are bad enough, but there's a whole spectrum of impacts below that level. And they're starting to find cumulative damage And so they want to set, although these standards haven't been established yet,
how many concussions you can sustain per game.
Exactly.
Which is crazy, because if you ask any neurologist, they will say one concussion is too many. Do not even get one. I guess, these sports have to exist, right? So,
and the protocol now, if you do get a concussion, is you're supposed to rest it for. You're not even supposed to play video games or do anything, even think. Well, because they want to cut down the blood flow. It's micro tears in the brain tissue, and so it's. It's not take out cross country running or something.
Suddenly, the average mass of a cross country team goes up by
exactly.
a tenth of a football player, right?
Yeah.
So that's what you're currently working on with your own company, Ambient Sensors?
That's one of them. I'm doing some weigh scale work and other different things that come along.
Is this just a one-man band company? This is just your own?
Actually, I have myself and a couple of other people now. I didn't really mean to have a company.
Right. Yeah, God damn it. I don't want to run a damn company.
Yeah. But I had done a startup before, and then I was working at the local university, but with the cutbacks and things, that job went away, so I just started this company as a way
so you're not currently working at the you're not a professor at the university?
I teach still for them. I just don't get paid very much.
Right. Okay.
Like this semester, I'm teaching engineering statistics.
Oh yeah, well, you're a funster. Yeah.
Yeah, they don't want to spoil the reputations of any of the other faculty on campus. So they have me right.
The whipping boy of teachers now, right?
So how does that work? Like, you get paid less, so you're considered a temporary teacher?
Well, they call it adjunct faculty.
Right. Okay.
Adjunct professor.
Yep.
And,
right. And I've heard that term. I never really knew what it meant.
It means you can only get paid very much, and you don't have tenure.
Yeah, right. Okay.
But I do it out of a sort of community sense, and also it keeps me involved with the university and all that sort of stuff.
So this is University of Idaho, is that right?
It's called Boise State University.
Oh, Boise State. Okay.
Yeah.
Why Idaho? Were you born and raised Idaho, or did you move there for some reason?
So Idaho is totally, like so many important things in your life, totally by accident. Yeah. Well, so when I was in my first incarnation as a graduate student, I was at Johns Hopkins working in X-ray astronomy, and we had an experiment that we flew on an Air Force satellite out of Vandenberg, and so I came out west. I had gone to school as an undergraduate up at Washington State University, and so I came out west for the satellite launch, and I went up to visit my friends at Washington State. And actually, Dave will relate to this. I was visiting with my friend, and his kid needed to have his diaper changed.
Right.
So while he was back changing the diaper, the phone rang, so he asked me to answer the phone. Well, it was another friend of mine that was working down here at HP, had just opened up a division, the disk memory division down here, and they were looking for people to staff it up. The reason why it's in Boise is because Hewlett and Packard used to like to ski quite a bit up in Sun Valley, and they even,
That's right. Yeah,
they even had a ranch up there.
Yeah.
And the guy who was the CEO at the time, John Young, was from Nampa, which is a small town close by. So there's no other good explanation except that just pure accident.
Serendipity. Yeah.
Yeah. Mm-hmm. But I did get in at early days in the disk drive business. Although disk drives back then were,
manly disk drives.
They were. Like, one of ours actually used a washing machine motor for the
gas powered,
right? But we also could sell them for amazing amounts of money. We had a 400 megabyte drive. I think it was about a $25,000.
Oh my God!
Piece of equipment back then. That's the thing that actually. so I graduated from college in '77. My
before you were born,
bachelor's
Chris.
degree. Yeah, I know.
Yeah.
And I was first licensed as a ham radio operator in 1967 when I was like 12.
Awesome.
Yeah, okay. And
Okay, that was before I was born.
I just want to establish a timeline.
that's good. That's
and
good.
just before that was dinosaurs, right?
All right,
So-
yeah. Well, according to people in some states in the US, yeah.
Yeah.
Exactly. So anyway, I forgot where I was headed with all that.
You said graduated in 77. That was, I think, where you started.
Yeah, but so disk drives, were still disk drives and microcontrollers and that kind of stuff were only available in big corporations.
Yeah.
And computers, basically. And PCs came out in the early 80s. But what amazes me at this point is how much access to technology there is. I just bought one of the new LPC Link 2s, their new debugger, and it's like $20.
I know. It's crazy.
And
Versus ice prices, right?
Yeah, and you can run Sager JTAG on it, or the NXT, or Red Probe, and all this other stuff.
Well, that's the thing. People don't realize before about 1990, doing your own microcontroller stuff at home was practically unheard of.
Yeah.
It was
impossible,
just couldn't afford
really.
the tools. Yeah, it was impossible.
Well, I remember Jack Gansel said he built his whole first business on doing an in-circuit emulator, right? I mean, like that was just
exactly.
an entire industry on its own. So
And now the
it's dead.
Oh, sorry.
No, go.
Now the tools have just gotten so amazing too. The software tools to do the development, and the same thing. Okay, so I feel so silly. So when I first did PC boards at HP, we actually used tape.
Oh,
on paper.
nice.
Oh yes.
and then took a picture of it.
Yeah.
Been there, done that.
And
Chris hasn't.
No.
and so things like Eagle are just amazing to me as well.
Yeah, I mean, having that at fingertips and everything, right? The CAD.
Although the other thing that's is I think very exciting is the kind of things like Dave's doing with his video and other people. That there's this community around the open source and Jerry's stuff. You can go out on the web now and learn so much if you want to. So being an autodidact is a much easier thing now than it used to be.
Yeah, less trips to the library, right?
Exactly.
Knocking on doors, begging to sit in the lab for a little while.
Well, but what's amazing is also how willing people are to help. So we were talking earlier about the Bluetooth Low Energy, and so I haven't ever done anything with Bluetooth Low Energy, and I had a project came up that really needed it, and started looking around, and there's this Jeff Roberg on an open source hardware site, and so I got in touch with him, and he's just turned out to be a ton of help in getting the Blue Giga BLE 112 up and running. And even was able to provide Eagle footprints, and so just being able to do stuff these days is amazing. And I think it's the synergy of all the people working together that make it so interesting.
Well, that used to happen before the communications revolution, except you used to send letters.
Yeah,
and you would, or you'd call people up on the phone. I'd get letters in the mail. Can you help me with this? So I'd spend all day writing a reply letter and lick a stamp and send it back, and that's how you communicated and shared information.
I have some really funny ones. My dad saved some of mine from when I was a kid, writing off to these big companies asking for parts, and I built a phase lock loop based radio teletype demodulator back in about 1970, and it was based on one of these brand new LM 565s, I think it was, a 567.
Yeah.
Oh yeah, it replaced a refrigerator-sized piece of hardware at NASA. Is one of the things they claimed at the time, which it probably did. And I ordered one, and the company thought I was some other big company or something anyway. So it showed up on Christmas Eve by special delivery and all this stuff. And I was just wanting to work on it over
Awesome.
and I built a board, and we had I forget why we had this. Our school had I think it was for exposing printing plates or something, a UV light
Like a
source.
light box?
So light box. And so I was able to take it to school and spray on the resist and then expose it through a negative that I got made. And
Man,
we're
looking that up on the internet, right?
Now I just send off Gerber files. And then boards come back in a few days.
Exactly.
So
magical world.
It is. It's hard to decide where to divide your time too, because you could go, do all these things still, but it doesn't
Tell
seem
us about it.
Worthwhile.
It's a bane of every engineer's existence these days, isn't it?
Yeah.
There's just too much stuff to work on, and just too much cool
awesomeness.
stuff to play with, and not enough time. I know.
Right.
I know.
It's crazy.
I've cut down on sleeping. Have you guys tried that?
Yeah,
Actually,
I'm trying that, but
Yeah.
wife doesn't get happy.
I've been reading a lot recently that you really should get 8 hours of sleep to be creative, but
Yeah, no, you totally should.
Well, some of my best stuff has been done with my eyes practically shut,
Oh, really?
Yeah.
That was under the gun probably too, right, Dave? It's not like self.
Oh, yeah, no, of course.
So-
Yeah, having that timeline. Yeah, that
Yeah.
time
I bet
limit
that
thing.
was more of the key there.
Possibly.
Yeah. That's one of my biggest motivators.
I just sit there like in a stupefied, sleepless haze, and I'm just like, I just click stuff at that point, but I still want to be doing it, right?
Right.
Yeah.
So tell us about this startup. This startup you did, because we always love hearing startup stories.
Well, this one, so most of the startup stuff you read, the Facebook stuff is all business porn, pretty much.
Yeah.
So this one, it was a fun project, but it nearly ruined me financially.
Yeah. Do tell. People love to hear these things.
You gotta be.
Take the good, you take the bad.
Be willing to lose all your money. Yeah.
Yeah, you gotta be willing to do that. I don't know. The problem is. Okay, so a startup should really be looked at as a business hypothesis that you're going to test out, and you should be dispassionate about it. And at the point where you've proven that it's not true, you should stop at some point. There was those inspirational posters that businesses like to put up,
like with the cat hanging out by a finger.
Yeah. Well, one with the ship, and so anybody can sail on. The one I always liked was winners never quit and quitters never win, but anyway, never mind.
Yeah.
I forget how that went.
I know.
Yeah, but
sounds like the posters worked.
Yeah. Excuse me. Okay, so the idea, I learned a lot from it. I'll have to say that I learned a lot. But the idea was a consumer product, and getting traction and the resources you need to do a consumer product's
That's tough.
really difficult.
Yeah.
Because the idea was, and this is okay. So this is back in 2001, 2002. You can also be too early into things.
Like pre-Kickstarter.
Yeah, pre-Kickstarter. So we had essentially a media center PC that was controllable through a wireless pad, but it was one of those early Windows CE pads.
Right.
And it had and it was pretty awesome. And we tried to differentiate it from just a big remote control by some of the things it could do. One of the things it could do is really simplify working with media that was on the internet. One of the other things it could do, though, is display video from security cameras, because the idea was that maybe you'd be watching the movie, but then the doorbell would ring and you'd want to decide if you needed to answer the door or something like that, or if you had a swimming pool and you wanted to monitor it. But the security part of it is what got traction, so we kind of pivoted at one point when we weren't really making many sales in the entertainment side into security, and then sold the company to a small publicly traded company up in Canada. But then the guys that bought it tried to cram down all the early investors, including all the people that invested with me and my own self, and it got, they actually succeeded in pulling a lot of the capital out and having the stock, because I thought when we sold it to a publicly traded company that would provide liquidity for the investors, which is what you're always looking for, and but they had as part of the sale, there was a period of time where they couldn't sell, and in that time,
they stripped it.
Yeah, they did.
Bastards.
And then we had to get lawyers, and it was a mess.
And then right.
It's not fun anymore.
No. Well, I learned a lot.
Right, that's what everyone says, yeah.
But it wasn't one of these deals where you work for 18 months and sell it for $1 billion to Facebook.
That's never happened.
No.
Well, Instagram.
Yeah, right.
Well, yeah, exactly. Yeah. But out of how many startups? Millions?
Right.
Yeah.
There's, a dozen success stories. Nobody ever talks about the failures. That's the problem.
No.
Well, not failures, but the non-success stories.
Well, if you look at it as a hypothesis, then either a positive or negative outcome is a good outcome because you've driven it to resolution. But the problem is if you get so enamored with your product that you don't quit when you really should.
You're right. Yes, that's yep.
But it was a close failure.
Missed it by that much.
Exactly. But one of the other things I learned was to do something, or to have at least some way to have an income early on. This other product, we worked for a year on it before we started trying to sell any. It's better to do something when you're first starting out that doesn't have unless you have somebody with really deep pockets to back it.
Yeah.
So the current company, right now, I have some projects in the background that are sort of longer term. So what I'm doing right now is more product development for other people, and the problem with that is it doesn't scale very well because you either got to charge
so many
more,
hours to sell in a day, right?
Well,
or work longer.
Basically selling your hourly rate, right? You're charging your hourly rate and you're a gun for hire. That's,
Exactly.
So there's no big payoff at the end. You just get continuous employment and you can eat. Congratulations.
Which is actually, so the way we're using it is, do some product development on the side and to try to be strategic about the projects that we take on. For example, this Bluetooth Low Energy project gets us involved in learning a technology, so that learning becomes kind of an asset of the company.
Yeah.
Right. Smart.
Smart.
Hopefully it turns out.
You're interested in this low energy stuff, Chris?
I am. Yeah, I have the. So you guys are using the 2540 chipset, right?
It's Blue Giga is the company in Finland. What they've done is put some nice. Well, they sell these modules first of all, which are FCC approved, so you don't have to put your equipment through
That's awesome. That's
a big
That's
saving.
the reason to do them. Yeah.
And then they also have provided a C API that you can compile if you have an external microcontroller with your code.
What's a talk over? Is it just talk over some serial?
Over UART?
Yeah.
Through the UART on the CC2540, but they also have something called Blue Giga Script, which is which allows the module to actually, because it has a 8051 controller in it, so the module itself, you can actually hook sensors directly to the module and run Blue Giga Script on it and not really have to hook up an external MCU to it, so it can be a standalone.
Very nice.
That's kind of cool.
And the other thing about Bluetooth Low Energy, so it's really Bluetooth in name only because it's really the very lowest levels, like the physical layer, that are Bluetooth.
Right.
Yeah, the stack on top is different, right?
It's very different, and it's designed for sending, bursts of structured data. So, if you have a thermometer or something, and it has a different way of hooking up. So it has if you have a sensor hooked to your Bluetooth Blue Giga module, and then it advertises that I've got temperature data. So anybody that walks in the room with a application can say, "Oh, that can attach to it," and
right. So it's like a Windows, it's like in Windows, like it's a generic USB microphone or something. It just knows that it's right.
Yeah, there's a thing called the general attributes file and packet that's part of the advertising that tells everybody what it can do.
Huh.
So whereas with traditional Bluetooth, you have to send a pin back and forth and do all this.
Right.
Yeah, it's like a handshake at that point, right?
It's really
traditional.
So it's really designed for sensors. And the Blue Giga script is a pretty cool way to program it, because you just need an XML editor, and then they provide an application that works with the TI CC debugger, the same one that TI supplies when you work directly with the CC2540.
Yeah.
And you don't have to install IAR and all that expense associated with that to program it then.
Yeah. That's it. I see a lot of interest in that kind of stuff. I mean, a lot of people, I see a lot of projects online switching over to Bluetooth finally. And if you think about it too, I mean, you think about Android devices or even iPhone devices too. There aren't that many ways to get into the phone, and that's kind of the de facto gateway these days, aside from going through the web. And
I was reading an interesting article yesterday, though, about what this is doing to Apple's ecosystem, because they used to require that you join this MiFi or MFI, MEFI.
Yeah, having that Apple chip on, unlike a wired device, right? That does the translation.
And if you were designing hardware for Apple, you had to use that 32-pin connector that they've got that's special and nobody else has.
Terrible.
But now with the Bluetooth, you can bypass all that. So that's a good thing.
Awesome.
And Bluetooth Low Energy is on some of the Android devices. They're on some of the Samsung Galaxy.
Yeah, and the HTC One, I think.
Yep.
I've been shopping for those. I was telling these guys before the show that I'm starting to shop for Google Glass stuff, because that has low energy, Bluetooth low energy stuff, but it's hard to find.
So you have to have
phones.
a specific phone with low energy support. Is that?
Yeah.
Is it a different chipset inside the phone? Is it?
No.
Or is it just one chipset that handles low energy mode?
I guess they probably have to have a dual mode.
Right. Chipset, yeah.
But that's pretty common. I guess that's the main thing. But then otherwise, it's just software.
Yeah.
Right.
And that's the key thing.
A regular Bluetooth phone can't talk to a Bluetooth low energy device.
No.
Right. Okay.
No.
I need a new phone then.
Yeah.
Yeah. But I think it's going to become more common. And you turn phones over every couple of years anyway. So.
Yeah. Right. I'm just a cheap ass.
Yeah, same here. No. I just keep cursing my phone instead of buying a new one. I just curse it every day.
I've got my Ericsson block phone.
There you go. Yeah, it's good for paperweighting and stuff like that, right?
So, but
I love it.
Anyway, it's good stuff.
What about some of the older stuff? I mean, so you'd sent a picture out the other day on Twitter, because you're very active on Twitter, which is great. And
I like to tease Akiba.
Yeah. And you had sent a picture of you in a hoodie, and you said, I was wearing hoodies before Zuckerberg was even born.
That's true.
Right.
That's true. So
what is in this picture?
Okay, what that is a system for measuring how the recording heads fly over the disk, and it's a heterodyne interferometer system. So I take the single frequency laser at 632 nanometers and split it, and then frequency shift it with these things called acousto-optic modulators. Those signal generators up in the corner of the rack, those are just to drive the acousto-optic modulators at certain frequencies. But what happens is when you recombine the light, you create an optical beat note.
Huh.
And the phase shift of the beat note, which you can bring that beat note down into the few megahertz range if you want, or even down into hertz. In fact, you can actually slow it down, just like you listen to a beat note between two tones, and you bring the tones closer in frequency, and you get that wah 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 thing. You can see this all in the optics. But what it does is it lets me then measure the phase by just measuring the phase of this like 2 megahertz optical beat note, and so I could get with the phase detector that I had, which had 1/10 of a degree resolution, I could measure, the lambda over 3600. In other words, 632 nanometers divided by 3600. So I was getting like 1/10 of a nanometer resolution and position.
Nice.
But with a 500 kilohertz bandwidth, and I, what I would do is form an image of the whole. So I would illuminate the whole head and the disc around it. And
so this is the actual the head of the
arm. Recording head.
Yeah,
out over because so in magnetic recording, the head's actually flying over the disc, but if the head separation changes, it modulates the amplitude and affects the error rate and other things.
Right.
Yeah, it's just to bleed over channels and stuff then, or
you can have that if things get really bad, but just back then we were trying to have raw bit error rates in the neighborhood of, it seems like 10 to the -8 or something like that, and then we'd boost it with ECC up into the 10 to the 10th.
And you're just doing this in the lab, right? I don't see like any, usually these hard drives are, vacuum sealed, right? They're sealed to keep out dust and crap.
Yeah, well, I did it was fairly clean conditions.
Fairly clean.
That's a clean hoodie.
It would smoke outside instead of inside, right?
Yeah.
Right.
Actually, it's funny that back then they did allow people to smoke inside.
Yeah.
But no, you notice the disc diameter there is about 14 inches.
Yeah, it's huge.
So, and the flying height was at the time seemed really small, but we were flying at like 19 millionths of an inch above the disc surface.
You drive a truck under that.
Yeah, exactly. And
you could have an earthquake on one touch, right?
Yeah. So we had, what we were trying to do was design the mechanical structure that held the head out there so that it wouldn't flap in the wind. And disk drives, they get pretty warm if you run them, especially if you can get some of those 15,000 RPM drives. They get pretty hot, and most of that heat is just the air friction. There's very little of it. Very little of it's actually the electronic heat, or the usual, electronic heat that we think about.
Yeah.
And so, designing the mechanical structure inside to deal with all that was a pretty good challenge. The disk drives were a lot of fun to work on because they had all these servo systems and mechanical challenges and magnetic challenges and electronic and
This is a great photo. You got to see it, folks. We'll definitely post this as your feature photo for the. I think, or would you prefer your Twitter photo? This one's awesome.
That one's fine.
Excellent beard, by the way.
Oh, thank you.
And so this is like a. Is this an anti-vibration laser table? It looks.
It's just a giant piece of granite. It was like
really.
It was 4 by.
That
6
works
feet
too.
by a foot thick.
That works as well, yeah.
And then the disc is actually on an air-bearing spindle, so the spindle's very low vibration, very low run out.
And what time frame was this? This was early 80s,
about
late 70s?
No, it's about 1981.
81, okay.
All right.
Yeah.
What model HP scope are you using there?
Oh, those were like 1740s.
Right. No evil Tektronix scopes in the building?
Oh, no. It was pretty funny when people would want to get something like that. I mean, sometimes they had to because that was, had the capability we didn't have.
What's this purchase order for this Tektronix scope?
Well, actually,
Heads will roll.
It wasn't so much that there was So HP was an awesome place to work when I started there. Very different than the company it is now. But it was 82 different divisions, and each one had a product, and each division was run as a small company. So Disk Memory Division was one of the largest ones. It had 300 people in it, but most divisions were 50 to 100 people, and they had all the functions of a small company. And the advantage of that was they were really close to their customers. The disadvantage is that HP looked at from 30,000 feet the way the CEOs and MBAs look at it. Looked like a real fragmented place, but it really wasn't.
Right.
But the so anyway, it was 1981,
and
very,
hoodies
very
were all
different
the
time.
rage.
Oh, what I was going, and what I was going to say is that so Agilent now was part of HP then.
Yeah.
So the reason that they broke up the company was again an MBA thing. They broke up the company because the stock on computers had higher multipliers than the stock on instruments, and so people thought if they broke it up, then the half that was computers could run at a higher multiplier in the stock market than the
That old short-term gain chestnut.
It was exactly.
It worked for a little while, right?
I don't think
I'm sure it worked a treat. Yeah.
It never worked very well at all. Every time they did a merger, 2 + 2 = 1.5.
Right.
never added it. Never even made it to 4, much less 5 or 6. But they always convinced people that it was a good idea. What I guess long way around to what I was going to say is that so we got these instruments for transfer at cost, they called it. So basically, we got the instruments for paying the bill of materials on it. We didn't
not even labor?
No.
Oh, wow. That's pretty good.
And so,
it's awesome.
And so we'd trade disk drives for oscilloscopes. And, of course,
alley deals. Yeah.
Disk drivers were worth a lot. So, so we had a lot of nice instruments. And Hewlett and Packard actually would come around. So like I've got this old HP signal generator that was Bill Hewlett. It was based on Bill Hewlett's master's work at Stanford, but
200, right?
Yeah, and I got them to autograph it. They were just around one time looking at it, so I got them. But they would do. I mean, they were the sort of people that you could just walk up to and talk to. And
that's so awesome.
Had a little bit of it. One of the nice things that HP did for me was they sent me back to graduate school, so I got my PhD back at Carnegie Mellon while working for Hewlett Packard.
Wow.
So I was like
awesome.
one of the better paid graduate students.
You mean paid?
Yeah, because the deal was they paid all my tuition books, plus I had 75% of my salary while I was going to school.
Oh my God, that's
I know.
Awesome.
They would never do that these days.
Yeah, these days, right? You
so
find any company that does that, right?
Yeah, so I wrote Hewlett a nice thank you note after it all was all over, and he wrote back, and it was just the kind of people they were. And
that's really cool.
Whereas I was in a meeting with, I think this is fair to tell. They can't fire me anymore.
Please do tell. Come on.
So I was in a meeting where they had all the sort of senior engineers. It was a technical meeting, HP internal technical conference, and
right, so there were hoodies as far as the eye could see.
Exactly.
Right.
And actually the HP guys were more like the old ham radio operators.
Suit and tie, skinny tie.
Well, it was always a jeans and t-shirt kind of place. It was always the only you never saw a tie around there, and if you did, people would make fun of you. But no, so we were there. This is when Carly first came in, and so if it was Hewlett and Packard, because I'd been to these kind of meetings before, they would come and have dinner or have breakfast. They'd always have a breakfast buffet beforehand in the morning, and they'd come sit at the table and talk and find out what was going on. Well, the way HP changed when Carly came in was we were sitting there having breakfast, and then over the PA system it says, now introducing the CEO of Hewlett Packard, Carly Fiorina, and she walks out on stage with spotlights and her sycophants in the audience, And then as soon as she was done, she took a few questions from some of the shills in the audience, then she said, "Well, I got to go," and walked off, and never talked to an engineer. So HP in the days when I was working there, and sort of the apex of it. I also worked down at HP Labs in Palo Alto. Was sort of a great engineering company to work for. And there's still parts of it that are good, but it's just not the same as it was. Because it used to
Yeah.
be really, really of, by, and for the engineers.
Right. I wonder if that kind of thing is even ever possible these days. I mean, like,
Oh, there are
I'm
companies.
sure it is. I think it is.
you think
there are
hardware
companies-
It's
though?
got to have the right attitude. I mean,
Yeah, I think so.
Hmm.
There are companies. Actually, Seagate is a little bit like that. At least the part of it that I've been to. They have.
it's very common in software companies like our team, who I used to work for. I mean, that
Yeah.
was a dream job. You know,
Yeah.
there was no management, no adult supervision, no meetings, no nothing. You know, it was just do whatever you want.
Yeah.
It was just, you know.
Actually, what they used to say is work smarter, not harder. But they really, and it was management by objective. They really took that seriously. So, however you could get, if you agreed to do something, and however you could get it done, they didn't.
Done, then that's it. Yeah,
Yeah.
exactly.
Yeah.
They didn't try to tell you how to do it.
That's good.
So if any of our listeners out there work at a company like that, please tell us.
I think
Maybe
Jerry.
we'll even have you on the show to talk about it.
Jerry did. I thought.
Well, yeah, until they gave her the arse, yeah, which we might hear about shortly.
I'm really curious to hear about that.
Yeah.
Oh, boy.
So speaking of management, I mean, so you said management by objective, which is that's the Bill and Dave thing, right? I mean, that's what
Right.
their
Yeah.
big thing was. But you actually had another management consultant, and I'm sure Dave will start groaning now that I bring it up. But you had someone sit in with you that's pretty famous as well.
Oh yeah, you were talking about Clayton Christensen, who's famous in the business management circles for his book, The Innovator's Dilemma, which actually is
Sorry.
a serious.
Go on then.
Well, actually, I saw it happen because what he did, I hosted him at here because he did his PhD work on studying the disk drive business, and
Yeah.
I saw the things that he described in there. I could really relate to because the things that he describes in that book really did happen in the disk drive world. But yeah, he was out when he was a PhD student, and I just hosted him around because he was collecting information on disk drive companies at the time.
Yeah,
And,
that was one of the big examples, and then I think he talked about like backhoe companies was another big one.
Yeah, well, in disk drives, you have these companies that come in and people kind of ignore them. Like for disk drives, it was Connor. We were building these big, high margin 14-inch discs, and Connor came in with a 5-inch disc that was kind of a toy, that went into like PCs, and it just the performance wasn't any good. Nobody thought it was. Oh, another thing that used to happen back in those days is people tried to protect their hardware by having proprietary interfaces.
Oh,
And HP tried to ride that for as long as they could, but the PC
SCSI cables
totally
came along.
changed that. Yeah,
Yeah, the standards came
Yeah.
in, and yep.
and the companies like Connor got better and became Seagate, and
Oh, is that what
It was-
started Seagate? I didn't know that.
I don't know the exact pedigree, but it's all entangled.
Yeah. Well, there's probably only so
it's
many.
a very
right?
incestuous web, the hard drive industry.
Yeah, it is. Actually,
Well, you got out though. I mean,
yeah. I did. The reason, so HP decided they couldn't make it anymore in disk drives, and whether they could or they couldn't is debatable. But they got out of that business, and so I.
By selling it, was there anything to sell off in the end, or had they just been totally trumped?
No, they just
folded.
walked
Right.
away from it.
Yeah.
There was some technology. They tried to capture some of the technology, but if you don't capture the people with, so giving somebody a stack of lab notebooks doesn't really do a lot of good.
here, fix this.
The big companies, do a lot of patenting, but the patent business for them is not so much about the IP and the patents as it's just the overall throw weight of who has, how many patents. And
Yeah.
so anyway, so the disk drive business it's funny because they sent me to school, and within less than a year of coming back from school, they shut down the division. And so I got involved in a tape project actually called Linear Tape Open, which was a new standard that got established, and HP was one of the companies that helped to establish that.
Tape, as in magnetic tape?
Magnetic tape, which is still used quite a bit in archive. If you think about a hierarchy of archive, you have, fast drives and then slower drives, and then still eventually when you get back far enough, you get onto tape, because the volume density, information storage density of tape is hard to beat. That's why I'd say you can't underestimate the transfer rate of a station wagon loaded with tape.
Right. Yeah.
Oh, the next step up from SneakerNet is WagonNet.
Yeah, but,
because it's sheer surface area, right? Because like I assume you can't get the same density on tape as you can on a hard drive, just due to the physical geometries and
pretty good,
stuff,
but not quite as good.
Not quite as good. But the fact is, it's very thin tape, and you can roll hundreds of 1,000 meters on one little spool.
Yeah, and it's
so.
And so the way the software that manages these storage systems is pretty amazing, because it can kind of work out and figure out which data is not being used very much and move it further down the hierarchy until eventually it winds up on tape, where stuff that you never.
Yep.
And it's all handled kind of transparently.
This is like cloud software you're talking about, like high level
big
storage?
data center software. Yeah.
Huh.
Is that like the? Well, I just have a friend who makes these big disk arrays now for HP, and they can store a petabyte. And I said, "Oh, you work on pedophiles."
Right. Yeah.
They can store a petabyte of data now, though. It's not a big deal. That's not uncommon.
Man, that's a lot of data.
Well, there's a lot of things making data these days.
That's true. Yeah.
And
Me? Sorry.
Yeah, the FBI's got to store all the phone messages that are.
And every video that I produce, so
exactly.
So that they can declare me a terrorist and
exactly. Just throw random words into your video like plutonium or something.
Yeah, I know. Yeah, White House and and president and exactly.
Yeah, that's a great idea.
Red flag. Awesome. Yes, that's my goal.
But NASA, each of those probes generates a lot of data too. So I don't know. There's a lot of places to store data. Facebook. That's kind of embarrassing. I remember when I started out, when I was at HP Labs and we were on the early ARPANET, and how I just felt insulted that they were starting to let commercial operations onto the ARPANET.
This is ours. And Bob, were you like the first troll? You're like, get these people out of here. Like,
I'm back on the old UUCP groups thing. And, well, it just seemed like it was, it was sort of commercializing something that was pure.
There goes the neighborhood.
We didn't lock our doors back then, and now I've got firewalls and antivirus and everything else. So, but I totally missed the whole web thing. I just thought that was a fad.
Really?
Oops. Yeah, these things happen, You'll get it next time.
How can you make money on that?
Yeah, right.
Facebook, that's a dumb idea.
It is kind of dumb.
But there's a lot of dumb people out there. That's the sheer weight of dumb people.
I still don't know how they make money on Twitter, but I guess they do.
No, I don't think they do yet.
I don't think it's a profit. Well, it's not a profit. I don't think it's a profit-making enterprise. But
you know what's amazing to me about Twitter is it's kind of like a cocktail party that never stops. So you can, I get on there and, Kiba's in Tokyo and micro builders over in Paris and Chris is on and VK2ZAY and all those people. And so there's always something interesting, and in fact I have to shut it off when I want to get real work done. Cause
Is your Twitter name, is that your ham?
Yeah, it's my ham call sign.
Right, WA7IUT.
Yeah.
Yep.
Right.
I was actually talking to people about, because I just got my radio finally, and I've been trying to find like the repeaters around here. And so I was asking about that, because I like, got it all queued up to the right frequency and everything, and I'm just sitting there waiting. And I go, well, what the hell is going on here, right? I mean, and someone says, well, there's Twitter, there's just tons of other ways to communicate, whereas before repeaters were it, right?
Chris just jumped on the
I just got to the party.
I didn't realize he's the only one left.
Yeah.
It is pretty quiet, I have to say, compared to what I remember. Cell phones. Now, out here in Idaho, it serves as real public service because there's lots of places where cell phones don't get. But
yeah, right. But yeah, I mean, just the repeater network before. I mean, it seems like that's what it used to be, and now, you just see there's a lot of I see a lot of call signs on Twitter, which is great because people are making these longer contacts.
Yeah.
And I think it's actually well, no, I didn't mean like that. I didn't mean like that. Although that is pretty funny. I meant that they try for the harder stuff with their actual antennas and stuff. That's what I really meant. Not that. Boy, this ham radio thing's easy.
They get on Twitter and set up their radio contacts.
Yeah, right.
Well, technically, if you're using a notebook, you're on wireless, right?
Exactly.
Yes, I pinged somebody in.
Yep. Yeah.
Well,
in Germany.
That's raised an interesting issue, though, because when I started out, I had lots of help, and I built a lot of electronics when I was a kid. It was made out of tubes, but it was still electronics. And nowadays, the maker movement and all the stuff that's been going on with the tools and things is a good thing. But there's been a period where people weren't really building a lot of hardware, it seems like.
Yeah, the 90s was to early 2000s was a dead zone. Yeah, it really was.
Well, everybody's getting excited about computers, right? I mean, Bob, it's your fault. You've made all these disk drives, right? I mean,
well, but that was the problem back in the 90s. That's all people cared about was computers. Electronics as a hobby had almost vanished. Mm-hmm. It was really quite dicey there for a while.
Yeah,
I thought the whole thing would actually vanish.
Yeah,
so
it seems to be coming back.
It wouldn't vanish, but like it would, it would, like all the magazines would die, and then nobody would care about it on the internet. But now, holy crap!
Yeah, it's a big change.
Love it.
It'll be interesting to see at Hamvention too, just to see if it. I mean, like I don't really have an idea of. If there will be less people than old videos showed and everything, but
there'll just be lots of old greybeards standing around tweeting each other.
Yeah, right.
Yeah, Chris mentioned it looked like Woodstock, and I said, "Oh boy." I don't know.
Don't want to see naked ham people, right?
No, not the ones I've seen.
Right.
I think I did notice at our local Hamvention a few weeks ago, which I went to, so I still stay in touch, that there were a bunch of younger people there, so that's probably a good sign.
Yeah, and Tony, who we've had on the show before, who talked about microwave stuff. I mean, he said, I think he sent me a link showing that the ARRL membership is up a lot more than it used to be too. So
yeah, and I like what Tony's doing with making the microwave stuff available to people.
Yeah,
I'm real tempted to jump into that.
Yeah, that's I'm just getting started in the quote unquote low frequency stuff,
Yeah.
High frequency for me used to be like 20 kilohertz, and now it's moving up a little bit.
That's another interesting thing, I think, because high frequency digital circuitry used to be I don't know what 50 megahertz,
10, 20 megahertz, 50. Whoa, hold on to your hat, folks.
And the radios now that are up in the 5 gigahertz and 10 gigahertz range that are all solid state digital things.
Crazy, like silicon, germanium, indium, whatever's in there. Yttrium.
Now we've got kids, building their own PCs with 4 gigahertz processors. And,
I know.
It's just, in socket, it's just ridiculous.
I was giving Akiba a hard time because I just built one of those recently, and I said I was going to put Linux on it so I could use VI and and awk and grep and stuff like that.
Yeah, well, I don't think you'd be alone in that.
But at 3 gigahertz.
Oh, right, yeah.
Actually, what is amazing about PCs also now is that you can throw these virtual machines on, and then you can have Linux and all this stuff all on one box running at the same time.
Yeah. Yeah, that's great for like troubleshooting. I mean, like I know I've worked with some people too that they'll throw an emulator on a virtual machine. It's not quite as fast, right? And then you have to kind of jiggle with the playthrough, the pass through of like USB or whatever you're debugging with. But you can actually have entire ecosystems of your like your compiler and everything else in a virtual machine, and then you boot it back up and you have that exact same system. So that's a nice little trick you can do too.
Yeah, I do that. Sometimes vendors will send you, like I got an Analog Devices A to D converter, and they sent along a little, well, it was really something that was based on LabVIEW. And,
yeah.
And it really wanted to run an XP, so I just set up an XP virtual machine and put it in there, and it didn't collide with my other LabVIEW. And yeah, so it's a great thing.
That's pretty cool.
Please, can we not talk about PCs anymore?
Okay, stop.
Consumer.
Yeah.
Consumer world.
Well, there's still tools we use though, right? I mean, it's like not like electronics getting away from it anytime soon.
They're just pens, really.
Right. No, that's a good way to use it.
Well, I have one on my bench, but it has a bunch of debuggers and
LT Spice.
Another thing that's kind of amazing is like these silly logic analyzers that you can hook onto your PC now and do a pretty decent job of analysis with that.
Yeah, versus the old huge Agilent or HP boxes, right?
Or having to buy one of these expensive, although they're not really, you can't really call them expensive anymore, but one of these more expensive scopes. Like I've got a Rigel scope here, the 1052, but I'm tempted to go to the new 2200.
2000?
Yeah.
Yeah, very nice.
And you would start to get... Yeah, I watched your YouTube on that.
Yeah, the comparison video of those two. Yeah, I know. It's amazing how far we've come in 4 years.
The other thing that's just awesome, and I bought it even though I really didn't have a use for it right now, which was the Rigel 815 Spectrum Analyzer.
Oh yeah,
which for $1,500, and it comes with a tracking generator and
amazing bang per buck.
I don't know, a year ago you'd probably have to spend $12,000 to get that.
Yeah, I know. And several years ago, the average person could not afford a Spectrum analyzer. If you're lucky, you got a second-hand old, boat anchor one off eBay.
Yeah.
But apart from that,
And this is a pretty decent one. Yeah. I mean, it's
not too bad. It's not going to do leading edge, stuff. It's
but neither am I.
Well, exactly, because it's phase noises. It's phase noises. Not
I'm not trying to build a cell tower here.
Right.
No, exactly. That's right.
Can it do 66 gig or what's the frequency?
No, it's only 1.5.
Yeah, 1.5.
Okay.
But it's good for your ham radio.
yeah, there we go. I mean, honestly,
I can
like that.
Look at the spectrum purity in my handy talkie.
Yeah.
So
that's pretty cool. See, you had mentioned, you're doing more open. You do some open source hardware stuff too. I mean, what is that? Some of the energy harvesting stuff you'd done, or what was that?
that was one project. Just try to give back in a small way because I've learned so much. So it's possible to be a double E and not actually do circuits. By the way. What I did mostly for HP was model magnetic materials and do computer models of actuators and disk drives and things, and I worked with some really interesting people, and that was a lot of fun, but it wasn't designing circuits or biasing transistors and stuff like that. So I've actually and I'm really attracted, I guess because of my personality, to the sort of self-learning that goes on, and so watching Dave's videos on how to do PCBs now, because I had to learn how. I found out that nobody tapes down PCBs anymore, so I had to go learn.
You use computers for that? What?
And so I had to learn a whole bunch of new skills, and but I feel like one of the things about openness and about open source hardware that I found is that you get back more than you could ever give out. And so I've been doing this little energy harvesting thing, which is more personal interest. I'm interested in wireless sensor networks, and we have one over here in a grape vineyard where we monitor the grapes, and that's a whole nother story. But the energy harvesting interests me because you got to be able to power the sensors out in the field. And so I built this little open source project, and I've gotten email from people all over the world about it that are just interested in it, and tried to help out some of them. A lot of college students that are trying to do a senior project on energy harvesting.
Yeah.
But, I would try to help them out as much as I can. So, yeah, and I went to the Open Source Summit, and that's a great thing. If for no other reason than I got to hang out with Akiva and Kevin Townsend and John Engineer and all those people back in New York.
I'm hoping to go to that one again this year. I went to the first one, but didn't.
Yeah, go to the one this fall, because I think everybody that I was with said they wanted to come back this coming fall because they had such a good time. I mean,
it's actually in Boston this year too.
Is it?
Yeah,
I didn't know that.
Yeah, I was surprised actually because it's actually not. So usually it used to be in New York. The past 3 have been in New York at like the Hall of Science, which is where Maker Faire is, or at Lightbeam, which is where it was last time, right?
I-Beam, yeah.
I-Beam, sorry, yeah.
Same thing.
And now the people who are putting it together, they're up in Boston, so they're moving it up 2 or 3 weeks, and then it's going to Boston. So.
Oh, okay. Well, that's fine. Boston's a lot of fun too.
Yeah, it's a great town.
So I went to the only thing I don't like about Boston is going to the Museum of Computers because this stuff all looks brand new to me. So I was like, what's this doing in the museum? It's still perfectly good.
So is this like the gift shop? Or,
yeah, really,
exactly. Where's the museum?
Actually, a lot of the computers that I worked on, the companies that made them don't even exist, like Data General and DEC. And
oh, yeah.
All that
crazy.
stuff.
Nope. I noticed you've got a HP multimeter on your bench there with a little handheld. Yeah, geez, you don't see too many of them around anymore.
Yeah, well, I don't think they make those. I just bought a brand new Fluke 289. They're true RMS voltmeter.
Oh, yeah, that's a good one.
It seems like pretty good.
With the shit battery life,
Well,
Yeah,
I go to Costco.
Costco.
How about you do some energy harvesting?
And I have a microcurrent here for the energy harvesting, the EEblog microcurrent.
Excellent.
I got it from Adafruit.
No.
There you go.
Excellent.
But actually, it's a great thing because one of the big problems with the energy harvesting and wireless sensor nodes is being able to figure out if how your software is affecting the current drain.
Yeah, exactly.
And but as you noted, and I guess that's why you make it, it's really hard to do measure microamps.
Nanoamps. Well, I originally made the story behind that is I originally made it because I wanted to overcome the burden voltage in the multimeter. It wasn't necessarily because I wanted to measure nanoamps.
Yeah.
It was just I found the burden voltage annoying, so I wanted to take that out of the equation. And I thought when I was designing, I could throw in a nanoamp range. Yeah, that might come in handy one day. And that's what most people seem to buy it for these days is the fact that it can measure nanoamps.
Yep.
So, and I just didn't. I didn't think that would be a target market.
I think it's
5 years ago when I designed it. So
I think it's perfect for that. Speaking of multimeters, the first multimeter, my dad was a ham radio operator, and that's partly how I got into it. But
that's awesome.
But he had one of those Simpson meters. That
the analog ones,
the 260 probably.
Yeah, and I would always. So my dad and I. Would butt heads quite a bit because I would use the tools and not put them back, and then he would come and want to do something and couldn't find the tools, and it was always. But he always wanted me to work with him on stuff too, so I guess it wasn't such a bad thing. But I used to burn out that meter every once in a while because I would because it's tube days and it's 300 volts, and you have it on ohms and stick it across 300 volts and burn out. And then you'd have to go replace the resistors in the thing, and
they weren't very forgiving.
No,
No diodes built in.
No
mercury valves or whatever would be the tube
well,
equivalent
I'm
of
not
diodes.
sure. Well, no, you usually wouldn't burn out the meter movement because I think the meter movement had diode protection across it.
Yeah,
I'm not sure about the Simpson 260, but most meters had back-to-back diodes across the meter, so you wouldn't blow that out. But as you said, you'd blow out input resistors.
The dividing resistors in there.
Yeah.
And so you'd wind them with, he worked out at Hanford, which was an atomic plant up in Washington State, so he had access to some laboratory gear. So we'd wind new resistors to put in the front end of the thing.
That's awesome. That's really cool.
Yeah, my first radios had mercury vapor rectifiers in them.
Yeah,
and the old OA2s, which had a nice argon glow to them. There's lots of smells and sensation, and my first radio had a 6L6 driving a 6L6 crystal oscillator driving a 6L6 final, and it was cathode keyed. So when you'd unkey the thing, it would come up to 300 volts, and if your fingers slipped off, you'd get the shock of your life.
Oh my god!
But stuff that you'd never get away with today. But it's amazing.
Yeah, right.
And I remember once this old railroad guy gave me he gave me boxes of batteries because they would replace the lamps with new batteries, and there were those 6-volt.
Like the wet cells?
Yeah, 6. Well, they were not wet. They were just, I can't describe them, but they're bigger than D cells, but they're
lantern. Well, we used to call them lantern batteries.
Yeah.
You mean like spring terminal on the top and everything? Like the 12?
And so I remember
12 volts or this? Yeah.
Yeah, 6. Well, they were 6 volts, I think.
Yeah.
And so I had, 50 of them. So I thought, well, let's just.
Yeah, of course, right.
Just whack them in series.
Yeah.
That made a really scary power supply.
Photonic induction is.
Exactly.
Yeah.
Well, you can do the same thing with 9-volt batteries today. You don't even need to wire them up because they just clip back to back, and you can get 1,000 of them, put them in series, and you can arc. You can arc shit over. It's really,
Actually,
it's really dangerous.
I was replacing all the batteries at a summer camp that we were helping out at and sticking them in my pocket as I went along one day. But I also had my keys in that pocket. All of a sudden, my pocket started getting real hot. Like, whoa, I know better.
The leg is melting.
Yeah, those 9-volt batteries.
And just before that, you used to ride a dinosaur to school.
That's right.
Yeah.
Actually, it's amazing what people used to do, though. Or what I can, because my first radios were all World War II surplus, but they weren't that old at that point. Because the war was only
20s
10,
of years.
15 years.
Yeah.
Right.
Or a Korean War surplus.
Yeah. Oh, there you go. Yeah.
Yeah. So
nice.
Chris, you've heard of the Korean War? I'm surprised.
Yeah.
Yes, I had some relatives serve in it, so. And also, I've seen MASH, so there's that.
Exactly. That's about what I know about it.
Yeah.
Well, they don't call it the Forgotten War for nothing.
But that's another thing that's kind of interesting is when I was a ham radio operator in my teen years, I joined this thing called a military affiliate radio service. So we actually handled traffic and phone patches for soldiers that were over in Vietnam at the time.
Really?
And
wow.
And what that was how people were able to talk to their families back then. And it was very sporadic because you know how hard it is to talk on HF from here to Vietnam anyhow. And
you got to wait for the right ionosphere stuff.
Yeah,
and
right? So we would pass messages and sometimes do phone patches for people, which would be very brief. And just because the conditions wouldn't support it for too long.
Yeah.
But now in Iraq or Afghanistan, they just have cell phones and
Skype, right?
Skype and talk. So that's another measure of how much things have changed. Because that was, the state of the art.
Yeah, that's pretty cool.
That led to, one of the things that the ham radio did lead to is I got my commercial radio telephone license, and then I worked on two-way radios when I was in high school, and that was a really good job for a high school kid.
Actually, what actually repairing them, or
Yeah. Well, I started out my very first job when I was 15 was working in a TV shop when they used to actually repair TVs, especially check the tubes and do all that stuff.
Yeah.
But then I got into it was a two-way radio business. So I worked for the local Motorola company, and they installed radios for the public utilities and people that and phone patches, even mobile radio. You used to have to call into an operator, and then they'd patch you into the telephone network. It's kind of crazy when you think about it.
Yeah, I mean that's just hanging out there then, right? I mean, it's not like it's like a private phone call at that point. It's like, well,
there's that too.
Yeah, you're basing it on the fact that people don't have radios,
I can remember listening into people's mobile phone conversations back when we had the analog network. It was on 700 megahertz or something, and I'd tune in with my scanner, and it was boring as bad shit. I'll be home at 7 o'clock for what do you want for dinner, honey?
Yeah.
Exactly.
I got this new phone. It's so cool.
but it's way different now.
Yeah. So what about so you're teaching now too, though? So you said statistics, but you have some other stuff on your like your research that you've done there and other stuff you've taught there. What was the one I saw in there? It was crud. I lost it. What are some of the courses you taught there? Oh, here we go. Finite element methods. Is that like actual magnetic finite element analysis type stuff?
Yeah, and antenna stuff.
Oh, antenna stuff. Okay, my buddy took a class for like transformers, and he did some finite element stuff.
Yeah. So when I started working in that, I started working with this group at McGill up in
Toronto,
Montreal.
Right?
Montreal.
Montreal.
And Pete Sylvester and these guys, and they adapted that method from what civil engineers used to do, but we used to use it to design electric machines like the actuators and disk drives, and the actuator has a certain force response, to the current going through the coil, but that becomes a gain block in the servo loop, and so you want to map out how that varies with angle, and we could model that with the finite elements because we could get an accurate model of the magnetic fields. And
so you would
it's a very common technique for all sorts of things.
Yeah,
very wide ranging.
FEA, you mean? Or?
Well, yeah, because you're solving the differential equations, and as Feynman said, the same equations have the same solutions. So I initially started out using a thermal model, which is just solving Poisson's equation, but it was for heat flow. But you could change the names of things, and then it became for magnetic materials.
That's awesome.
But then there's some special things that Maxwell's equations do that thermal things don't do that you had to take into account. And so we developed our own, programs for doing that. And actually you talk about the disk drive business being incestuous, but the finite element world is really like the guy that started ANSYS and HFSS and all that.
Those packages.
Zoltan Sendes was a graduate student at Pete Sylvester, who was the guy that I was working with at McGill. And so I taught some courses in that because it's a neat way to. There's only about 3 or 4 problems you can actually solve in electromagnetics by hand, and then you have to go over to
exactly.
computer methods. But that came along with digital computers too, and the rise of PCs and the power of what you can do with those. And so those tools are, and there's a lot of interest in kind of mixed physics models now. So you have eddy current heating, and that couples into a thermal model, so you can model the actual.
It's like holistic now, almost. It's like current creates heat, affects current, back and forth kind of thing.
Yeah, they do. Actually, you can.
Wow.
In the magnetic world, that's sure the case.
Just because the materials change, or what?
The materials have changed. Most things have magnetic properties that are dependent on temperature.
Oh.
And in fact, what they do in disk drives now, they've gone over to real heroics in disk drives, because there's something called the superparamagnetic limit, which has to do with if you keep making the bits smaller and smaller, you get to a point where just thermal energy can cause them to flip on their own.
Yeah,
and the way
it's nasty business.
And the way that you prevent that is increase the coercivity, or the resistance to change of flipping. But the problem with that is then you have to increase the fields that come out of the recording head, and you reach a point where you really can't push it any further. So what they're doing now in the current generation of disk drives is they use a laser to temporarily suppress the coercivity by heating the material, and then you write on it and then turn off the laser, and it cools quickly and sort of freezes in the magnetic pattern.
Wow. This sounds like I mean, like, just hearing about this stuff, I mean, I'm very impressed with all this stuff, but it's just like
of cards.
It's amazing that like there's so much energy spent on this. Not even energy, but just like so much brain power to just keep squeezing more data on there. I know that it's an economic driver thing, but man, it's so cool.
Well, you can buy little terabyte drives at Costco now for That's the result of it.
Right.
And
and then we, put Jersey Shore. We store like digital editions of Jersey Shore. I mean, like that's the ultimate thing that my brain goes to. Yeah, or Facebook. Yes.
But actually, the story of the increase in areal density, they call it, the bits per square inch in disk drives, is pretty amazing, because it's gone up at a very consistent rate over the years. That's just like orders of magnitude every few years.
Yeah. Is there a Davidson law or what?
No.
who got named after that one? I mean.
Oh, the superparamagnetic limit? I don't know. It's just called we're not as clever. We just call it, let's come up with they wouldn't have the marketing guys working with us, so we'll just call it the superparamagnetic limit. That's what I used to say.
That's catchy.
Yeah, they said if HP sold sushi, they would call it cold dead fish. Somebody else came up with the name sushi to make it sound good. That was the problem with HP. But the neat thing about HP is it was selling to other engineers, so we kind of knew our audience.
Yeah, exactly. It doesn't matter if
the difference.
If the test equipment's all four-digit numbers, right? You just you assign your own value in your head of it's something awesome, right?
And the internally we used to talk about the next bench phenomenon, that you would see what the engineers needed on the next bench and then develop
on the next bench and then
tool to support that. So
that's crazy.
I think our time's almost up.
Yep.
Yeah, I think so too. But I think we could probably keep going for another 3 hours, 4 hours.
Yeah.
I mean,
as usual.
I've got more woodchuck here. I'm going all evening.
I had to ask what this woodchuck thing was. I had no idea before the show.
Yeah, it's hard cider from Vermont.
Delicious cider. Yep.
And it's got a woodchuck on the front of it.
Yep.
I didn't even think you could buy cider here. I don't.
They have apples.
I don't. Well, you probably can, but don't hear of anyone drinking cider here.
Do you have apples?
Yeah.
Well, they probably have cider. They may make apple juice, and they probably get cider eventually.
Yeah, exactly.
Well, yeah. Well, you can buy apple juice. Yeah.
Some parent leaves it in a sippy cup too long, and then they think, well, we should keep doing this.
Just leave it under the sink there for a while.
Yeah, there you go.
Yeah. Right. Okay.
Don't put it back in the fridge and.
Yep. Well, Bob, thanks so much for being on the show. I mean,
absolutely.
We'd love to have you back on sometime and hear more about what you're doing
and where can we find you? Where can we follow you?
If
people want to see more Hoodie HP photos.
Oh, well, those are kept in the archive, but
well, bring them out. I'd love to see this.
But I'm WA7IUT on Twitter. That's my ham radio call sign. And then www.ambientsensors, all one word.com. So
lots of good projects and blog posts and stuff on there. And you said you're getting back into.
I'm getting back into doing that. Yeah, I am.
Awesome. Thanks, Bob.
And we'll see everyone next week.
Catch you later, Bob.
Okay. Take care.